Hello, welcome everyone. Today we are continuing our forces and motion, and in that, actually, it's a whole complete topic that I'm talking about, and in that, I'm doing displacement, acceleration, and time. Last time we have seen that how can we solve or how can we get any parameter from the graph, from the velocity time graph on the displacement time graph. But today we'll be doing if we have no graph, only just the word problems given and how we can calculate this. But before that, I'm running a Gcse batch classes for all the subjects. So if you want to book a demo, just email us at exactadmin@gmail.com, or if you want to enroll for any year for any subject, same, just email us for at exactadmin@gmail.com. So let me start. If we are doing algebraically how to calculate velocity, time, any missing parameter, we have three equation of motion. See, these are not Newton's equation, they are just equation of motion. So here is the equation of motion. First is v is equals to u plus at. Second is s is equals to ut plus half at squared. And third is v squared is equals to u squared plus 2as. Now let me see these notations. What does the mean of u, v, and so on. So v is always final velocity, which is in meters per second. U is initial velocity, also in meters per second. S is your displacement, that is in meters, that is your standard unit. Time is in seconds, and A stands for acceleration, that is in meters per second squared. So these are equation of motion. Now, after the equations of motion, there are two terms that we have to know. First is average velocity and second is average speed. See, definitely if a body is accelerating, that means its velocity keeps on changing. It doesn't mean that we generally talk about the initial and the final velocity, but throughout the journey, if a body is accelerating, that means definitely it keeps on changing its velocity. And same can be said for the speed. Obviously the speed cannot be constant. So that's why there is a term called average velocity and average speed, but they both are different. For average velocity, because it should depend on initial and final position, so average velocity is initial velocity plus final velocity over 2. That means v plus u over 2 will give you average velocity. Whereas if you talk about the average speed, that doesn't depend on your initial and a final speed. You don't do this like adding up, or suppose 4 or 5 different speeds are given, so you just take out the mean and it will give you average velocity, average speed. No, it's not the case. Average speed is always total distance covered by total time taken. So this is important. Now, after these three equations of motion and these two formulas, let me do some questions. It says, calculate the vertical distance covered by an object if a man has thrown it into air with a speed of 10 meters per second. See, this is the ball and man has thrown it upwards in air. So you have to calculate the vertical distance covered before it reaches to its maximum height, and the speed is 10 meters per second. That means initially speed is 0 and final speed when it's up there will be 10 meters per second. So if I see any equation of motion, speed is given, definitely. Vertical distance, so if something is vertical, acceleration is always g, acceleration due to gravity. That means if something is thrown in vertical direction or if something is falling, so here g will play your a. So that means acceleration is given to you. velocity, initial, final velocity, and you have to calculate displacement. The two equations out of three equations of motion that has displacement in it are these two, which is s is equals to ut plus half at squared and v squared plus u is equals to u squared plus 2as. Now you have to see that which you have to apply. Time is not given at all, that means clearly I need to pick this third one. So that means I'll apply v squared is equals to u squared plus 2as. Now velocity, acceleration, these are vector quantity, and if something is a vector quantity you have to take the consideration of the sign as well. If ball is thrown upward, gravity is downward, so what will be the acceleration of ball? It's moving upwards opposite the gravity, so it will be negative g. So acceleration, if you're throwing something from a height, so your ball is in direction of gravity, so the acceleration that your ball will gain is equals to plus g. Whereas when you're throwing opposite to it, so the acceleration that your ball is gaining is opposite to it, that means negative g. So this equation will become v squared is equals to u squared minus 2gs. Initial velocity is 0 because when you are throwing it, initial is 0. Final velocity is given as 10 minus 2gs. Let me take the value of g as 10. Until unless they haven't mentioned that it should be specifically 9.81, 9.8, you can take it g as 10, that you have to mention, taking g is equals to 10 meter per second squared. So 100 over negative 2g's displacement, that means s is equals to 100 over negative 20, which is negative 5. Now you might be thinking, okay, distance can never be negative. See, the negative shows you that it will be in opposite direction, right? Just like, because we have taken that if body is moving upward, we are taking the negative direction, simple. So negative 5 represents that it is moving upward, and obviously it has traveled upwards, but it says vertical distance covered. The word distance they are using, so we will not consider the negative sign. Instead I'll write 5 meter or upward. They have already mentioned the direction, then there's no point of using the negative sign. They are asking you just the distance covered, and it's going to be 5 meters. Question 2. A body of 40 kg is under influence of 400 Newton of force. Calculate the distance covered by this body in starting of 40 seconds if it moves in a straight line. See, now first, whenever we do the mechanics, because I feel that student really struggles in understanding the questions of mechanics. They can do current on questions on electricity, they can easily do it on nuclear, but when it comes for mechanics they get really confused. So first thing is, just write down the parameters that are given. In this, force is given, time is given. If force is given, I can calculate apart from it mass is given. That means F is equals to mass times A. That will give me acceleration. And what they are asking, to calculate displacement. So let me use F is equals to ma to calculate acceleration first. Force is 400, mass is 40. From here acceleration will be 10 meters per second squared. Now time is given. They are asking displacement. That particular, because out of three equations of motion we have only two equations of motion which contain displacement or distance in it, s in it, and in that two, one has time and one doesn't have time. So obviously we'll pick that one which has time. That is your second equation of motion, which is s is equals to ut plus half at squared. Initial velocity was 0, so I'm taking it 0. So s is equals to half, a is 10, time is given as 40 seconds, 40 squared. This will be 5 times 1600. That will give you answer as 8,000. 8,000 meters or 8 kilometers. Moving on to the question number 3. A car starts from rest and travel 200 meter in 10 seconds. S is given, which is 200. Time is given 10 second. Initial velocity, because they have mentioned from rest. From rest indicates your initial velocity is 0. Find the average acceleration of the entire journey. A, they are asking you. Again, either I can use the first one, which is v is equals to u plus at, which has time, or we can use the second, but displacement or distance is given. I'll use second equation of motion. The parameters will decide which equation of motion is required. If S is given, quickly it should come in your mind that I have to select second or third. Then time is given, so which one has displacement and time both in it is your second equation of motion. And also they are asking acceleration, that you can easily calculate through it. So applying it, displacement is 200, initial velocity is 0, half times a times 100. So acceleration is 200 over 50, which is 4 meters per second squared. Calculate the final speed of the car. Which two equations of motion have initial and final speed? V is equals to u plus at and v squared is equals to u squared plus 2as. We have both, and fortunately in both of these equations, see, if I write v squared is equals to u squared plus 2as, v is equals to u plus at. We know initial velocity, we know displacement, we know acceleration. I can calculate final velocity with the help of either of this equation, because the parameters are known for both. So I can pick either of them, will get the same answer. So let me pick v is equals to u plus at, which is simpler. Final u is 0, acceleration is 4, and time taken was 10. So final velocity is 40 meters per second. Now calculate the average velocity. We just saw average velocity is initial velocity plus final velocity over 2. Initial velocity is 0 and final velocity is 40. So 0 plus 40 over 2. That is 20 meters per second. So these are just some of the questions, and I have cleared you the basic that how you can calculate any of the missing quantity if a graph is not given to you. Definitely in the next lecture I'll be uploading the harder questions on it and the different types of questions on mechanics or algebraic word problems where we can calculate these parameters. So that's it for today. I'll again say that if you want to enroll for one-on-one or for batch classes from year 1 to year 13 for all subjects, just email us at exactacademy@gmail.com. So that's it for today. Thank you and have a great day.